Continuing with inverses, we're going to start concentrating more on the domain and range of both our original function and the inverses. For this section, we're going to do a little bit of review and then we'll get into more restricted domains. So our first example, we're asked to take our original function and find the inverse. So our first step, we're going to rewrite f of x as y in our equation. Then we need to flip the x and y. We need to switch them. So we get x is equal to y minus 4 to the 7th plus 9. We need to solve this for y. So I'm going to rewrite this with my y on the left-hand side. Just a preference. You could continue to solve our equation for y when it's on the right-hand side, but it does get some confusing for some students. Next up, we need to subtract that 9. So I'm going to copy down the y minus 4 to the 7th. We get x minus 9 because we moved it from the left side to the right side by subtraction. To get rid of our 7th power, we need to take the 7th root of both sides of our equation. And the whole reason that we do this is so that the 7th root and the 7 will cancel each other out, which means we're left with y minus 4 is equal to the 7th root of x minus 9. Add 4 to both sides to get the y by itself. And we have y is equal to the 7th root of x minus 9. Last step, we need to replace the y with our inverse notation. Since f of x was our original, we're going to say f inverse. And I dropped my plus 4 in the last one. Sorry about that. So our f inverse is equal to the 7th root of x minus 9 plus 4. Keep in mind that the 4 does not go under the radical because we took the radical or the 7th root of both sides before we added the 4. Okay. Now that we have both of our functions, we can go ahead and do domain and range of each. And I'm going to use the chart again, just for organizational sake. And because it does help with finding the domain, finding the ranges. Okay. So let's see, we have f of x, we have f inverse. Okay. So if we look at f of x is a polynomial. And remember, polynomials are our friends. Polynomials don't have any restrictions or issues, which means that our domain is negative infinity to positive infinity. And if we found the domain of the original, that means that we found the range of the inverse. So the range of f inverse of x is also negative infinity to positive infinity. If we look at our f inverse function, is a radical function. And remember, radical functions happen with one of two outcomes, and it's all dependent upon the index. So our index is the little number on the radical, and here it's 7, which is odd. Because we have an odd index, our domain is again negative infinity to positive infinity. Which means that the range of the original is also negative infinity to positive infinity. Remember, the domain of one is the range of the other. So this inverse and the original function didn't have any restrictions. But we have already viewed a couple of functions that do have restrictions, and those are our rationals. We're asked to find the domain and range of both the original function and the inverse. And here this guy is a rational function. Remember, that's just a fancy way of saying that you have a fraction on steroids. It's got variables showing up in numerator, denominator, everywhere. So rational function, our restricted values come from the denominator. Okay, so this does have restrictions, but we'll take care of the domain and range after we find the inverses. So our first step, we need to replace g of x with our y. So we have negative 5x plus 11 all over 2x minus 3. Step 2 says that we switch x and y in our equation. So x is equal to negative 5y plus 11 all over 2y minus 3. And because we have our y in the denominator, we're going to multiply both sides of our equation by that denominator, 2y minus 3, because we don't want the 2y minus 3 in that denominator anymore. So on the left-hand side, I have x times 2y minus 3 equal to negative 5y plus 11. Okay. Because we have y's showing up everywhere and we need to get our y's to one side and everything without a y to the other side of the equation, we need to take care of this x. We can't divide both sides by x because then we're going to have our negative 5y trapped with the x underneath. So we're going to distribute our x all the way through our parentheses. So we're going to have x times 2y gets us 2xy. X times negative 3 gets us negative 3x. We have negative 5y plus 11. Move everything with an x to the right side, everything with a y to the left. So let's go ahead and add 3x to both sides. When we do that, we're going to have 2xy equal to negative 5y plus 3x plus 11. We need to get all of our y's to one side, so I'm going to add 5y to both sides. Remember, you can skip this step if you're comfortable doing it in your head and go straight to 2xy plus 5y equal to 3x plus 11. And now notice on the left-hand side, we have a y in both terms, which means that we are going to factor out the y. We'll have 2x plus 5 in parentheses equal to 3x plus 11. Divide both sides by that parenthesis, and we get y is equal to 3x plus 11 all over 2x plus 5, which means that we just found our inverse, which in this case is g inverse of x. is equal to 3x plus 11 all over 2x plus 5. Let's try circling that without cutting off all my numbers. Okay, we still need to do the domain and range of both of our functions. So I'm going to go ahead and write my chart. And we're going to give ourselves a little bit more room than we did in the last one, our last chart, because we're going to have some longer function domain and range to write. Yeah. So let's find the restricted values of g of x, so the domain of g of x. We're going to take our denominator, set it equal to 0. When we add the 3 and divide by 2, we find out that x cannot be 3 halves. And if you want to do the little number line, you can. And the only number on there is going to be the 3 halves. And remember that you cannot be the 3 halves. So our domain of our function, the original, is negative infinity on up to 3 halves with a parenthesis, union 3 halves to infinity. Notice I didn't even take my own directions, that I needed more room. So here we go. And of course, technical issue. Sorry about that. Give me a second. There we go. And because we found the domain of the original, we found the range of the inverse. So we get negative infinity 3 halves, union 3 halves to infinity, and make sure that you have parentheses around those 3 halves. Next, let's find the domain of our inverse. Start the same way, take our denominator equal to 0 to find our restricted values. Subtract the 5 and divide by 2, and we find out that x cannot be negative 5 halves. If you set yourself up with the number line, only negative 5 halves is going to be canceling out. So our domain is going to be negative infinity to negative 5 halves, union 5 halves to infinity. And if we found the domain of the inverse, we found the range of the original. Again, negative infinity to negative 5 halves, union negative 5 halves to positive infinity. So you've actually already been working on finding functions with restricted domains and their inverses. It's just it didn't really refer to it in that way, but our rational functions fall into that category.